Yes, good evening, students, everyone. Janvi, Davangere students, good evening. Good evening, how are you? And others, Chitradurga, Tumkur students, good evening. Okay, nice. How are the students? Are they doing good? Are they uh, are they doing their homeworks and all? I'm good. I'm good. I'm good, students. Thank you for asking. So, how was the day? How was the full day? Was it tiring? So, give me some 2 minutes of time. So, let me just set up everything and we'll begin the class. Okay. And yes, Chitradurga students, good evening. And students who are joining in from YouTube, good evening. Yogesh, good evening. Good evening. Okay, Yogesh, nice, nice. Had your tea and all, Yogesh? So, students, there is some issue in the poll and all. So, let's do one thing. Let's, before starting the session, please let me know is my audio, is my screen visible or not? This goes to both Zoom and YouTube live students, okay? योगेश मैंने पूछा कि आपने टी चाय पी लिया क्या ओके दावणगेरे स्टूडेंट्स ओके गुड दावणगेरे स्टूडेंट्स आई एम फ्रॉम दक्षिण कन्नड़ डिस्ट्रिक्ट थैंक यू दक्षिण कन्नड़ मंगलूर सो नान मंगलूर nice okay others students please let me know Uttarakhand students Tumkur students Davangere Ballari Suman please let me know is my audio is my presentation visible or not please let me know okay Yogesh let me know is my screen visible or not for you okay Uttarakhand students very good thank you for your answer okay good okay students yes how are you all just a second I'll just pin myself in the audio sorry video okay good nice so shall we begin then so my name is Samanvit your physics faculty from Avantifellows and I have been teaching you what students Newton's laws of motion and let's say we are at the end of this chapter okay nearly at the end because from now on we'll be solving numericals but there are certain concepts as I told you there are certain concepts that has to be what completed to solve the problems so based on the solution let's say if we solve for 2-3 more classes then during that time there will be certain concept also okay or we might take next week completely to complete all the numericals or different types of numericals today also there will be numericals so based on that numericals you will be very thorough with the Newton's laws of motion okay students okay Yogesh thank you thanks a lot okay now coming into what we'll study today okay first thing is the first basic thing is what the quick recall yes every time we do it and we need to do it today also such that you remember everything okay so tumku students so have you gone through the previous video at least one video yeah Ballari students I don't know who asked yesterday is it Tumkur or Ballari students next we'll be talking about acceleration of a body down a rough inclined plane so what will be the acceleration value when there is an inclined plane and it is moving what downwards okay it is moving downwards then we'll talk about what work done in a moving a body up a rough inclined plane so basically we want what work done then we'll talk about whether it is easier to pull the body or push the body like push the body or pull the body okay is it good students okay and next we'll be talking about what numericals okay numericals based on what friction now over here You need to apply all the Newton's law, that we have learned, and also now you have to add what? Friction. Now friction comes into picture, students. Is it good? Now friction comes into picture. Good. Now students, in the last class, do you remember what we have studied? Let me know in the chat. Trishna, Sweetie. Okay, Sweetie, Trishna, good evening. I just wanted to check whether Sweetie has come to the class. Sweetie, Trishna, Suman, and all. Yes, Madhya has come. Good evening, everyone. So let me know what we have studied in the last class. You and me. Okay, very good. Okay, very good. Others, Davangere students, Ballari students, Tumkur, Uttara Kannada. Do you remember? At least do we remember the concept or the heading what we have studied in the last class? Okay, Suman and Sweetie, very good. See, in the last class, okay, Madhya, very good. In the last class, we talked about what? See, we have talked about limiting friction in the previous class also. So, like day before yesterday, in the last class, we talked about specifically kinetic friction. Yes, as I said, what is happening over here? Let's say we have a body of mass m, and I'm applying a force A applied. You know that if the applied force is greater than the limiting friction, then there is motion. Yes. Now, students, as I said, if there is motion, then the friction that comes into picture is what? The frictional force that comes into picture is the kinetic friction. Yes. So kinetic friction or a dynamic friction is the opposing force that comes into play when one body is actually moving. Yes, over the surface of the another. Yes or no, students? Do you remember this? And we came to know that this friction basically is proportional to the normal. Yes, you know that. And we know that this can be written as Fk is equal to mu k into n. This also we saw. And what is mu k, students? Do you remember what is mu k? Let me know in the chat. Let me know in this chat. Mu k is what? Coefficient of what? Kinetic friction. Coefficient of kinetic friction. Yes, Davangere, Tumkur students. Yes, very good, very nice. Yeah. See over here, this kinetic friction, as I said, what is this example? Let's say you are pushing a wall. Yes or no? Not a wall, sorry, a wardrobe. You push ಮಾಡಬೇಕಾದ್ರೆ what will happen when you're trying to push? As I said, there is this sound. Yes, over here. I hope you can hear this. Can you hear this? Yes. Did you very well? I'm pushing my desk. Okay, nothing else. Yeah. So yeah, over here, see, I overcome the limiting friction. Since I applied a force, see, I'm applying a force, it's not moving. Okay, now and applying more force, then only it is moving. Then the kinetic friction comes into picture. Why? Because the body is moving. But as I said, there is this friction is there. And also I said you that this kinetic friction is less than the limiting friction. And this means that the mu k, oh, my table is moving now. Okay, mu k is what? Mu k, that is coefficient of kinetic friction, is less than mu s. Yes. Okay, Yogesh, good. So see, there are people who prefer English also, so don't worry. मैं हिंदी में बात करूंगा. Where are you from, Yogesh? Let me know. Where are you from? Okay. Is it good? पता चला सब कुछ. Very nice. Now, and also we saw the loss of kinetic friction. क्या loss था? The force of kinetic friction is directly proportional to the normal reaction. अभी मैंने बताया कि force is directly proportional to normal. अगर मैंने नॉर्मल ये प्रोपोर्शनलिटी कांस्टेंट को हटाया तो हमें क्या मिला? Mu k n. This is k. And kinetic friction doesn't depend on the surface area of the contact. See, every friction, that is limiting friction, static friction, kinetic friction, it doesn't depend on area. It doesn't depend on what area? Any area. Because why? See, formula में पता चल रहा है ना? Because formula is depending on what? Mu k and n. बस काम खत्म. And the third thing is what? Force of kinetic friction is independent of speed or sliding or lowering. As I said, see, अगर एक body है और move कर रहा है with the velocity v, okay, some velocity, okay, a meter per second, जो kinetic friction होगा, ये अगर मान लो 2 meter per second था और 3 meter per second हो गया, फिर 5 meter per second हो गया, इसको फर्क नहीं पड़ता, जो भी काइनेटिक फ्रिक्शन होगा ना एफ के, वो कांस्टेंट ही रहेगा, वो कांस्टेंट ही रहेगा। मतलब अगर 2 मीटर पर सेकंड के लिए अगर 0.6 था, तो 3, 5, 10 जो भी होगा 0.6 ही रहेगा। इज इट गुड? ओके, यूएनए योगेश, आई डोंट नो, कैन यू फुल्ली टेल वेयर आर यू फ्रॉम? अच्छा, हिमाचल प्रदेश, ओके, गुड गुड, नाइस, ओके, नाइस नाइस प्लेस योगेश। Okay, yes. So students, let me know. So do you remember all these things? Yes. Then we talked about a graph. Do you remember the graph, students? So the graph was against what and all? ग्राफ के किस किस के बीच में था, याद है आप लोग? याद है आप लोगों को? लेट मी नो, किसके बीच में था? स्वीटी, जेनवी स्टूडेंट्स, एवरी जेनवी स्टूडेंट्स, व्हाट वाज द लेट्स से वाई एक्सिस ग्राफ? ये कौन सी डायरेक्शन में? ये वाई एक्सिस ले लिया, अगर एक्स एक्सिस ले लिया तो वाई एक्सिस में कौन सा आ रहा था, बताओ? हाँ, फोर्स ऑफ फ्रिक्शन, यस, फोर्स ऑफ फ्रिक्शन और फ्रिक्शन फोर्स। नहीं नहीं नहीं, जो यहां होता है ना वो अप्लाइड फोर्स होता है। यस, यस और नो? यहां होता है फ्रिक्शन फोर्स, ओके, फोर्स ऑफ फ्रिक्शन और फ्रिक्शन फोर्स। ओके, वाई उत्तराखंड स्टूडेंट्स, ओके, इन ओके, Chitradurga students, here is the force of friction, and was here it is the applied force. Yes, here it is the applied force. Applied force. And you know that what static friction is a variable friction, and it will be constant according to the applied force. Yes, it will be constant according to the applied force, and there will be a linear curve. Then you know that there will be a limiting friction, and due to which there is this bump. There is this bump, and you know that after this there is this kinetic friction, because why? Limiting friction के बाद, limiting friction अगर मतलब overcome कर दिया, अगर applied force applied is greater than F limiting, then क्या हो रहा है? मोशन हो रहा है। मोशन में क्या आ रहा है? मोशन में फोर्स काइनेटिक फ्रिक्शन आ रहा है, और आपको भी पता है कि जो काइनेटिक फ्रिक्शन है वो कांस्टेंट रहेगा थ्रू आउट द मोशन। यस, कांस्टेंट रहेगा थ्रू आउट द मोशन। So if I take this, you know that if I'm taking this area is basically what? This is kinetic friction, sorry, static friction, yes. And over here, this is what? F limiting. And over here, this is what? F kinetic. Yes or no, students? Let me know in the chat. Do you remember this? Yes or no? Yes. Let me know quickly. All of you, do you remember these things? Yes. Okay, good, good. Very good. Very nice. Now, then we talked about what? Angle of friction. Yes. What is this angle of friction? As I said, see, अगर एक नॉर्मल है, एक बॉडी है, ठीक है, और वो एक सरफेस में है, एंड यू नो दैट एक नॉर्मल है, एक फ्रिक्शनल फोर्स है, बिकॉज देयर इज अ व्हाट, सॉरी, लिमिटिंग फोर्स है, एक लिमिटिंग फोर्स। यस और नो? क्योंकि अभी हमने ये नहीं बताया कि F इज ग्रेटर देन, ठीक है, हम एक फोर्स अप्लाई कर रहे हैं, है कि नहीं? नाउ एज आई सेड, दिस एंगल इज व्हाट? द एंगल ऑफ फ्रिक्शन। फिर मैंने बताया कि अगर आप इसमें यहां शिफ्ट करोगे तो ये क्या होगा? F लिमिटिंग होगा, और ये क्या होगा? ये वाला नॉर्मल होगा। सो आपको tan थीटा क्या होगा? tan थीटा इज व्हाट? F limiting by n, and you know that mu s is equal to what? F limiting by n. Now students, we get tan theta to be what? Mu s. Yes or no? And theta is equal to tan inverse of mu s. Yes or no, students? Let me know. Let me know in the chat. Yes. Okay. Good. Very good. Okay. This was the formula. Then we talked about what? Angle of repose or angle of what? Sliding. So what was happening? Let's say we have a inclined plane, and there is a mass m, and you know that if this mass m has what? Normal, and there is one what? If this is what? Mg, this is mg, and this is will be theta, and you know this is mg cos theta, and this is mg sin theta. And you know that if it is sliding, there is what angle of repose is defined as the angle of inclination of a plane with horizontal, such that a body placed on plane just begins to slide. You know that if there is a verge of sliding, the force, the frictional force is what is the limiting force. Yes, yes or no? Now you know that over here you can write. How can you write? How did you write, students? Let me know in the chat. See over here, you know that F limiting equal to mu s into n, and you know that mu s is normal is what? Normal is what? Mg cos theta. So mg cos theta. But as I said, students, this theta will be basically alpha, because at that angle there will be what? Sliding. So can I write from this mg sine alpha equal to what? Mu s mg cos alpha. From this I got what? Tan alpha. Mg cancels out. I got tan alpha to be what? Mu s. And this was the, just a second, sorry. Tan alpha is equal to what? Mu s. Yes, students? Do you remember this also? Yes or no? Just a second, students. Let me just yeah. Good. Okay. Now, so many have joined. Any new person has joined today? Any new person? Tumkur, Davangere, okay. Ballari, Bagalkot, okay. Nice. Okay. Now, talking about what today, what we are going to talk about. Okay. Today, we will be considering the acceleration of a body down a rough inclined plane. Basically, देखो, there is a inclined plane. ठीक है, एक inclined plane है, यहाँ inclined plane है, and आपके पास एक बॉडी है. ठीक है, एक बॉडी ऑफ मास m. ठीक है, एक मिनट रुको. a body of mass m. ये यहाँ सब सही है. मुझे ये बताओ, इस बॉडी पर क्या क्या फोर्स एक्टिंग कर रहा है? कौन सी फोर्स एक्ट करेगा? यू नो दैट देयर इज अ नॉर्मल फोर्स, ये भी पता है आपको. यू नो देयर इज अ वेट एक्टिंग, दैट इज mg. यू नो दैट देयर इज अ दिस कंपोनेंट, दैट इज mg cos थीटा. और आपको पता है कि यहाँ एक mg sin थीटा एक आ रहा है. yes or no, students? Now you have to apply the acceleration formula. मुझे ये बताओ, if the body is accelerating, you know that if it is accelerating, अगर मान लो एक रफ इंक्लाइन प्लेन एक्सेलरेट कर रहा है, then मुझे ये बताओ कौन सी फ्रिक्शन एक्ट कर रहा है? कौन सी फ्रिक्शन एक्ट करेगा if there is acceleration? If there is acceleration, which friction? Others, let me know. Uttarakhand students, very good. Chitradurga students, very good. Ballari, Tumkur students, let me know. Which, if there is acceleration, if there is a what? Acceleration means what? There is motion. If there is motion, students, which one is acting? You know that there is what? The kinetic. Yes, sweetie, very good. Okay, Suman. Okay, there is what? Kinetic friction that acts. Yes, there is a kinetic friction that acts. Now, students, can I write Fk is equal to mu k into n, and आपको पता है कि n और ये mg cos theta क्या कैंसिल आउट करेंगे या बैलेंस आउट करेंगे? So can I write n equal to mg cos theta? सही है. So उसके बाद I can write Fk is equal to what? Mu k mg cos theta. यहाँ तक सही है स्टूडेंट्स? लेट मी नो. यहाँ तक सही है? यस. नाउ स्टूडेंट्स, अब मुझे ये बताओ स्वीटी, लेट मी नो, अगर एक एक्सेलरेशन हो रहा है और इस साइड हो रहा है, सो कैन आई राइट फ्रॉम न्यूटन्स लॉ ऑफ मोशन, जो सेकंड लॉ है, कैन आई राइट अगर ये नीचे जा रहा है, कैन आई राइट mg sin थीटा, और सिंस ये वाला ऊपर मिल रहा है, सो माइनस एफ के इक्वल टू m इंटू ए. ये लिख सकता हूं मैं? लेट मी नो स्टूडेंट्स, लेट मी नो. अगर हमने FBD करा, इसका जो FBD की वजह से आ रहा है ना, ऐसे लिख सकते हैं ना? लेट मी नो. Let me know, students. Yes, good, good, very good. Now, students, can I do something? I'll substitute this second equation in one. So if I substitute, it will be mg sine theta minus mu k mg cos theta equal to m into a. ऐसा भी लिख सकता हूँ. Okay. Chitradurga students. Okay, listen. No problem. You know that there is this component mg cos theta. ये वाला एक component है. Sorry. ये वाला एक component है mg cosine theta. And if this body is accelerating along this side, okay, अगर यहाँ accelerator हो रहा है, ठीक है, आपको पता है कि जब हम FBD करते हैं, अगर हमने FBD बनाया from FBD, ठीक है, आपको पता है and F इज इक्वल टू एम ए लिखेंगे ना, तो आपको क्या F नेट फोर्स लिखना है कि नहीं? नेट फोर्स, जो ये वाला फोर्स है, देखो ये एक नीचे एक्ट कर रहा है, हौदा ಚಿತ್ರದುರ್ಗ ಸ್ಟೂಡೆಂಟ್ಸ್, ಇದು ಕೆಳಗೆ ಆಕ್ಟ್ ಆಗ್ತಿದೆ, ಇದು ಮೇಲೆ ಆಕ್ಟ್ ಆಗ್ತಿದೆ, ಕರೆಕ್ಟಾ? ಈಗ ಆಕ್ಸಿಲರೇಟ್ ಈ ಕಡೆ ಇದ್ರೆ, ಆಕ್ಸಲರೇಷನ್ ಈ ಕಡೆ ಇದ್ರೆ, ಇದು ಪ್ಲಸ್ ಆಗ್ತದೆ, ಕರೆಕ್ಟಾ? mg sin theta, and the net force will be basically ಎಂತ, ಇದು ಎಂತ, this is basically net force, ಇದು net force. ಯಾಕೆ? mg sin theta ಒಂದು fk से अटैक ಆಗ್ತಿದೆ, which is in the opposite side, so it will be mg sin theta minus fk, ಹೌದಾ? And we want what? F is equal to m into a, that is f net equal to m into a, and it will be what? mg sin theta minus fk equal to m into a. ಗೊತ್ತಾಯ್ತಾ ಚಿತ್ರದುರ್ಗ ಸ್ಟೂಡೆಂಟ್ಸ್? let me know. Oh, okay. Davangere students, see, you know that there is a body of mass m, okay, and you'll resolve into components mg sin theta and mg cos theta, mg sin theta, mg cos theta. Now, as I said, see, acceleration of a body down a rough inclined plane. Now you know that the acceleration is along this direction. Yes, let's take this direction. Now you know that there are two forces. Agar ye iga yava force act ಆಗ್ತುಂಟು ಕೆಳಗೆ ಬರ್ಲಿಕ್ಕೆ, mg sin theta is responsible to what? To make sure that that body is coming down. Yes, I can't on the video. Can you see me? There is yeah, it is very black. Okay. So what? This mg sin theta is responsible to make sure that body is coming down. Okay. But as I said, ಈಗ ಕೆಳಗೆ ಬರ್ತಿದ್ರೆ, you know that there is this force fk is acting. ಎಂತದು? Kinetic friction is acting. Yes or no? ಈಗ kinetic friction act ಆಗುದಾದ್ರೆ, can I write the F net force that is acting on this body as, since A is acting along this direction, as mg sin theta, which is responsible for acceleration, minus fk, which is trying to stop it. So ಹೀಗೆ ಬರಿಬೋದಾ? Let me know. And you know that F is equal to m into a. So F net equal to m into a. So I wrote this equation basically. Yes, let me know. Yogesh, let me know. Davangere students, others, if you have, if it is clear, let me know. Davangere students, okay, good, very good. Now I got what? Now I got mg sin theta minus what? mu k mg cos theta equal to m into a. Yes, can I cancel m and m, and can I write g sin theta minus mu k g cos theta equal to a, and this is the formula for what? For acceleration of a body, for what? For acceleration of a body down a rough inclined plane, students. So please note it down. This is an important equation. Please note it down. What is it saying? It is saying g sin theta minus mu k g cos theta equal to a. Okay, this is what it is. Good. Let me know. YouTube students, let me know. Okay, Bagalko students. Sweetie, Krishna. Sweetie, समझ आ रहा है? Okay, good. Yes, Suman, very nice. Madhya, let me know. Madhya, आप भी बता देना, ठीक है? Okay. Krishna, nice. Now, students, if that is the case, please try to solve this. Please try to solve this. I'm giving you exactly 2 minutes of time to solve this. Okay? एक बार solve कर देना ये क्या है? देखो, क्वेश्चन क्या बोल रहा है? अब ब्लॉक स्लाइड्स डाउन इंक्लाइन प्लेन एट एन एंगल 30 डिग्री. ओके, 30 डिग्री पे क्या इंक्लाइन कर रहा है? विद g इक्वल टू a इक्वल टू g/4. फाइंड द कोएफिशिएंट ऑफ काइनेटिक फ्रिक्शन. सो क्या हो रहा है कि एक बॉडी है जो एक इंक्लाइन प्लेन पे है और स्लाइड कर रहा है, ठीक है? अभी हमने देखा उसके लिए एक्सेलरेशन क्या आ रहा है, ठीक है? देन यू नीड टू फाइंड द कोएफिशिएंट ऑफ काइनेटिक फ्रिक्शन, जो म्यू के है उसको फाइंड आउट करना है. सॉल्व कर दो एक बार. सो ट्राई सॉल्विंग इट. प्रीवियस फॉर्मूला यूज करना है. लेट मी नो. बहुत इजी है. And let me know the answer, students. Let me know the answer in the chat. Genuine students, let me know. Did you understand the problem? And should I give you more time to solve it? Let me know. Let me know in the chat. And are you able to solve it or not? Let me know. Very good, sweetie. Very good. Tumko students, very good. I guess you missed it too. Very good, Uttar Kannada students. I'll give you 30 seconds more, okay? जिनको ट्राई करना है वो 30 seconds more ले सकते हैं, ठीक है? And YouTube students, let me know also, okay? Answer क्या है इसका? Is it minus? Minus आ रहा है क्या? चित्रदुर्ग students, check ಮಾಡಿ ಒಮ್ಮೆ. Yes, yes, Ballari students. Very good, very nice. Everyone is answering. Okay. 3, 2, 1. Okay, sweetie, very good. Suman, 1. Okay. Ballari students. Okay, one ನಿಮಿಷ. Ballari students, ಆನ್ಸರ್ ಎಂತ ಒಮ್ಮೆ ಬರೀರಿ, ಯಾಕೆಂದ್ರೆ ನೀವು 2 ಸಲ ಬರೆದ್ರಿ ಅದಕ್ಕೆ. ಓಕೆ, ನಾವೀಗ ಸಾಲ್ವ್ ಮಾಡೋ ಇದನ್ನು. ಈಗ ದೇರ್ ಲೈಕ್ mu k we need to find out. Yes or no? We need to find out mu k. Yes. Yes, Ballari students, very good. And they said that there is this block that is being slide. Yes, it's sliding. And we know that for that acceleration is there. Yes, if there it is sliding. And you know that if it is slide, and what, there will be a kinetic friction that is acting. Now students, ega we have all this information. We have this angle theta which is 30 degree. Yes, and acceleration is given to be g/4. Now just now we saw a formula to find what the acceleration, that is what a equal to, let me know what was it. What was it? G sin theta minus just a second, minus, okay, so many insects are coming, okay, Just a second, students. So there are a lot of insects here. No, Suman, check kar, एक बार check कर लो. G sin theta minus mu k G cos theta. Okay. Now you have A, you have theta, you want mu k s. So A is what? A is G by 4 equal to G is G, we don't know, let it be G. Sin theta is sin 30 degree minus mu k is to be find it out, and G what? Cos 30 degree. Now students, can I cancel G cancel out to 1 by 4. Sin 30 kitna hai? Sin 30 is 1 by 2 minus mu k cos 30 is what? Cos 30 is root 3 by 2. Now students, can I take this over here and take this over here? So if I do that students, will I get mu k root 3 by 2 equal to 1 by 2 minus 1 by 4? Yes or no? मैंने इसको इधर डाला और इसको इधर. So 1 by 2 minus 1 by 4 is how much? Mu k root 3 by 2 is what? Basically what? 4, 2. Yes or no? 2 minus 1. Yes or no, students? So it is mu k equal to 1 by 4 into 2 by root 3. 2 1s are 2 2s are. So mu k comes out to be what? 1 by 2 root 3. Yes, this is the answer. So everyone who has answered it, very good. Okay. Everyone who has answered it, very, very good. Is it good? Yes, students, let me know. समझ में है सबको? Suman, let me know. YouTube students, let me know. Yes, good, very good. Okay, Chitradurga students, very nice. Madhya, let me know. Suman, let me know. Now, coming into work done in a moving a body up a inclined plane. Okay, so basically what they're asking, you need to find the work done. ये बहुत easy है. And you know that, see, you have gone through this also. Work done is what? Force into displacement. Yes or no? Force into what? Displacement. Now students, they're saying, what they're saying is, there is an inclined plane. Okay, there is an inclined plane, and you have an object, and you want to move this object with the force F. Okay, moving body up a rough inclined plane. Yes. Now students, if this is mass m, you know that there is a force acting, that is normal, and you know that there is a mg that is acting. Just a second. There's mg that is acting, and you know that if this is the angle theta, there is a component mg sin theta, and here that is acting what? Mg cos theta. Yes. Now students, what they are asking is, if I'm moving this object by a displacement s, then find the what? Work done. Work done is what? Force into displacement. Now students, the displacement is s, and you want force. What is force? So can I write force? See, over here, you know that the force that is required to move this object up the inclined plane is what? Let me know. Students. देखो, मुझे ये बताओ students, let me ask you, अगर मुझे इसको ऊपर लेकर जाना है, if I want to take it upwards, then you know that there will be a static friction also. Sorry, there will be a kinetic friction that will be acting. Yes or no? Fk. What is US into N? Suman, let me know. There is this kinetic friction that will act, because why? We want to move it up the plane. Yes or no? Yes or no, students? Let me know. Yes. Now, can I tell the total force that is required to move this up the plane is what? F is equal to what, students? Mu k n plus mg sin theta. Can I tell this? This is the force required in moving a body up a rough plane. Yes. Can I say it, students? Let me know. Very good. Others? So now can I write work done to be what? What, students? Force. Substitute this mu kn plus mg sin theta into displacement plus ho gaya s, and this is your formula. This is your formula. Okay, did you get it, students? Let me know in the chat. Let me know quickly. Let me know. YouTube students, let me know. Good, good. Marco students, very good. Okay, Uttarakhand students, I'll tell you. Okay. See, over here, there is a body which is kept over here, and you want the body to move upward. You know that if the body is trying to move upward, then there is this kinetic friction that is acting, and there is this also a component that is acting, mg sin theta. Yes? Yes or no? Uttarakhand students, let me know. Very good. Okay. Now, you know that the force that is required can be written as this force, this total force. So, illi namige ಒಂದು force ಬೇಕು, which will help us to move it upwards. Then can I say this force is equal to mu k n plus mg sin theta? ಮಾಡಬಹುದು ಹಾಗೆ? The total force. ಹೌದಾ? ಇದನ್ನು ಕ್ರಾಸ್ ಮಾಡಿದ್ರಲ್ಲ ನಾವು ಮೂವ್ ಆಗುದು. So can I write mu k n plus mg sin theta? ಅದನ್ನೇ ನಾವು ಇಲ್ಲಿ ಬರ್ದದ್ದು. ಹೌದಲ್ಲ? ಯಾಕೆಂದ್ರೆ ವಿ ವಾಂಟ್ ದಟ್ ಫೋರ್ಸ್, ಅದಕ್ಕಿಂತ ಜಾಸ್ತಿ ಬೇಕಲ್ಲ, ಅಂದ್ರೆ ಆ ಫೋರ್ಸ್ ಈಕ್ವಲ್ ಇದ್ರೆ ಮೂವ್ ಆಗ್ತದೆ ಆರಾಮ್ಸೆ. ಹೌದಾ? ಬಿಕಾಸ್ ದಿಸ್ ಇಸ್ ಕೈನೆಟಿಕ್ ಫ್ರಿಕ್ಷನ್. ಸೊ ಕೈನೆಟಿಕ್ ಫ್ರಿಕ್ಷನ್ ಯಾವಾಗ ಬರುದು? ಮೂವ್ಮೆಂಟ್ ಇದ್ದಾಗ ಅಷ್ಟೇ. ಅಂಡ್ ನಾವೇನ್ ಮಾಡಿದ್ವಿ, ಇಲ್ಲಿ ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡಿದ ನಂತರ ವಿ ಗಾಟ್ ವರ್ಕ್ ಡನ್ ಅಷ್ಟೇ. ಎಸ್, ಗುಡ್. ಅರ್ಥ ಆಯ್ತು ಈಗ ಎಲ್ರಿಗೆ? Understood everyone? Let me know in the chat. Yes. Okay. Can I know who is replying from JNV Uttarakhand? Can I know? Now. Okay. Now students, I want to ask you whether it is easier to push or pull a body. I want to ask. Let me know whether it is easier to pull or push. Which is it? Which do you think? ಈಗ ಒಂದು ಬಾಡಿ ಇದ್ರೆ, if I'm trying to pull the body is easier or push the body? Okay. Janvi Chitradurga students told pull, and everyone else is saying push. Okay, very good. Very nice. Now, okay, let us try to understand this. Now, let me take two scenarios. One is pull scenario. Okay, pull scenario. Let me take a body of mass m. Now, I will try to pull this body with the force F. Yes. Now, students, you know that there is this weight acting. Weight is equal to m into g, and there is a normal force acting. Yes or no? Now, students, yes. Let Ballari students, let's see. I'm asking whether it is pull or push. Those two things. It's not about the mass. I'm asking whether it is it easier to push or pull the body? ಅಗರ್ ಎರಡು ಸೇಮ್ ಮಾಸ್ ತಗೊಂಡವೆ ಆಯ್ತಾ, ಎಂತಂದ್ರೆ ಈಗ ಮಾಸ್ ಸೇಮ್ ಉಂಟು. ಈಗ ಒಂದು ಬಾಡಿ ಉಂಟು, ಲೆಟ್ಸ್ ಸೇ ಒಂದು ಬೆಂಚ್ ಇದೆ, ಡೆಸ್ಕ್ ಇದೆ, ಏನೋದಿದೆ. ಅದನ್ನು ಪುಲ್ ಮಾಡ್ಲಿಕ್ಕೆ ಈಸಿನಾ ಪುಷ್ ಮಾಡ್ಲಿಕ್ಕೆ ಈಸಿನಾ ಅಂತ ನೋಡುವಂತದ್ದು. ಮಾಸ್ ಸೇಮ್ ಉಂಟು, ಡಿಪೆಂಡಿಂಗ್ ಆನ್ ದ ಮಾಸ್. ಈಗ ನಾವು ಪುಷ್ ಮತ್ತೆ ಪುಲ್ ಎರಡಕ್ಕೂ ಸೇಮ್ ಮಾಸ್ ಸಿಗಲ್ಲ ಮಾಡುದು, ಹೌದಾ? ಎಸ್. ಈಗ ಕ್ಯಾನ್ ಐ ರಿಸಾಲ್ವ್ ದಿಸ್ ಫೋರ್ಸ್ ಇಫ್ ದಿಸ್ ಇಸ್ ಆಂಗಲ್ ಥೀಟಾ into two components, F cos theta and F sin theta? Yes or no? This component. Just a second to make sure that you don't confuse. This is F sin theta. Yes or no, students? Now, students, can I write this normal component to be over here, which is required basically, or let's say Okay, students, let me know. Is there any doubt? Let me know. Okay, good students. See, let me take this to be N1. Okay, this is the normal force N1, and this is the what weight that is acting. So can I write the normal force to be N1 to be? You know that. See, अब देखो इस body में mass is act over here. You know that there is a normal force N1 acting, and also you know that there is a F sin theta acting. Yes or no? And downwards, what is acting? Mg. So can I write, students? Can I write over here this as N1 plus F sin theta is equal to Mg? Yes. And can I write N1 is equal to Mg minus F sin theta? ऐसे लिख सकता हूं? ये सही है. Let this be equation 1. Okay, ये pull के लिए. अब I'll write for push. Okay. Similarly, there is a body of mass m. Okay. Now you are trying to what? Push it. You are trying to push it with the angle theta. Okay. There is a force F. Now, students, can I again resolve this into two components? That is what? F cos theta and what? Students, this one F sin theta. And you know that there is a normal force that is acting N2, and there is Mg. What? W. Weight is equal to Mg. So for this, if I do the FBD for this, there is what? There is a normal force acting, that is N2 on the upper side, and at the downside there is what? F sin theta, and there is another Mg. Yes. So can I write N2 to be students? Let me know. How can I write N2? Can I write N2 to be Mg plus F sin theta? Mg plus F sin theta. And this is the second equation. Let me know, did you get it? N1 and N2. So what is happening over here? N1 is equal to Mg minus F sin theta, and N2 is Mg plus F sin theta. Now, students, I want to ask you, between 1 and 2, which is bigger? Yava quantity or konsi quantity is bigger? N1 quantity is bigger or N2 quantity is bigger? By seeing. Yes. Sweetie, Trishna, yes. Ha. Very good. So what is happening? You can see that N2 is bigger than N1. Yes. इसका मतलब क्या है कि जो नॉर्मल फोर्स लग रहा है वो ज्यादा है ना N2 के लिए. हाँ, मैंने प्रीवियसली बताया था कि हमारे पास F लिमिटिंग क्या होता है? म्यू के म्यू लिमिट म्यू एस इंटू एन. तो मुझे ये बताओ, अगर नॉर्मल फोर्स ज्यादा है तो जो फोर्स है, लिमिटिंग फोर्स है, वो ज्यादा है. यस और नो? वेरी गुड. अगर नॉर्मल फोर्स कम है तो लिमिटिंग फोर्स कम है. यस और नो? तो मुझे ये बताओ अभी कौन सा इजियर है फिर, पुल या पुश है? किसमें ज्यादा हमें नॉर्मल फोर्स दिख रहा है? वी आर सीइंग दैट पुश में N2 लग रहा है एंड पुल में N1 लग रहा है. यस और नो? सो विच इज इजियर टू पुल, पुल और पुश? Yes. So students, from that we get to know that, from this we get to know that what students, pull is easier than push. Pata chala? So only, I guess, Chitradurga students have told the right answer. Very good. Okay, very good. Yes. So this is your answer. So clap for yourselves. Okay, I guess it's Chitradurga students. Did you get it, students? Let me know in the chat. Okay, Yogesh, very good. Thank you. Yes, good. Others. Let me know with a thumbs up or a tick mark, anything. Or a message. Okay, good. Uttarakhand students, let me know. Tumkur. Okay, Bagalkot students, very good. Suman, very good. Now, if that is the case, students, now students, we are going to what? Numericals. So remember, students, you need to apply both Newton's law, and what? And the friction, itself. Okay. Now, students, here is the first question for you guys. Okay. Here is the first question for you guys. This is very, very easy question. So I want you guys, everyone to try it. Okay. It is very, very easy. Now, see, I'm giving you exactly 3 minutes of time to solve this, but let us go through the question first. I'll give you 3 minutes. Okay. See, over here, the question says a heavy box of mass 20 kg is placed on a horizontal surface. So they're saying there is a surface of 20 kg, it is kept. Okay. If coefficient of kinetic friction between the box and the horizontal surface is what? Mu k. So they have given mu k is 0.25. You know that then if that is the case, then the body is accelerating. Calculate the force of kinetic friction. So they want what? The force of kinetic friction, that is Fk. Okay, Uttarakhand students, Fk is good. Okay. And they're saying that also calculate the acceleration produced under a force. So they want acceleration is how much under a force that is being applied, that is 98 Newton. So please solve this, students. Please solve this. Yeah, that is Fk. I want acceleration too. So please solve it. Yes, I want acceleration too. So find out what Fk and what is acceleration. Okay, students, very good. See, you can take G to be 10 meter per second square. Okay, it will make your calculation easier. Tumko students, very good, very good. Davangere students, very good. Chitradurga students, check your answer. And Uttarakhand students, please let me know your answer. Check your answer once. It's not the right answer. Yes, sweetie, very good. Bagalkot students, very good. Chitradurga students, check your answer. Yes, Ballari students, very good. Chitradurga students, very, very good. Uttarakhand students, very good. Suman Madhya, please let me know. Okay? Krishna. Okay. So time's up. Time's up. Time's up. Okay. Now students, over here, देखो इसको हटाते देखो अब यहाँ अगर मैंने इसकी एफबीडी बनाऊंगा तो क्या होगा, देखो यहाँ 20 kg है और आपको पता है कि एक नॉर्मल एक्ट करेगा और एक वेट एक्ट करेगा, दैट इज व्हाट 20g, yes or no, that is m into g. Now you know that there is a force that is acting, F is equal to 98 Newton. Now you know that if the force is acting, then there is this kinetic friction that is being acted, and you want that first. You know that what mu k is 0.25. Now आपको पता है कि आप कैसे फाइंड आउट कर सकते हो, सी पहले आपको फॉर्मूला है, यू हैव फॉर्मूला म्यू सॉरी एफ के इज इक्वल टू म्यू के इंटू एन. देखो n पता चाहे हमें, n इक्वल टू 20g लिख सकता हूं मैं, विच इज बेसिकली n इक्वल टू 200 लिख सकता हूं, लेट मी नो, ऐसे लिख सकता हूं मैं. यस, सो एफ के इक्वल टू व्हाट 0.25 इंटू 200. एंड अगर मैंने इसको हटा दिया ये 100 हो जाएगा, 0 0 कैंसल्स आउट, विच इज व्हाट 50 न्यूटन. अब हमें पता चला जो ये है, जो ये वाला वैल्यू है वो है 50 न्यूटन, है कि नहीं. अभी हमें पता है कि जो एक्सेलरेशन होगा वो इस तरफ होगा. तो बेसिकली फ्रॉम सेकेंड लॉ वी नो दैट A is equal to what, F net divided by the mass. Now you know that the total force that is being acted is what, एक 98 न्यूटन है, एक है इस साइड जो है what 50 न्यूटन. yes or no. Now if that is the case, you have acceleration is equal to F net कितना होगा, acceleration इस साइड है तो ये वाला प्लस होगा 98, ये वाला माइनस होगा -50 डिवाइडेड मास कितना है, mass is how much students, mass is 20. So A equal to what, 98 minus 50 is 48 divided by 20, ये हो जाएगा A is equal to what 24 divided by 10, which is basically what 2.4 meter per second square. Got it? And this is your answer. So क्या हमें F के आया 50 न्यूटन और हमें एक्सेलरेशन आया 2.4 मीटर पर सेकेंड स्क्वायर. सो यू नीड टू अप्लाई बोथ द कॉन्सेप्ट नाउ, जो फ्रिक्शन हमने पढ़ा है और बाकी जो भी है. Yes students, let me know. Clear. Let me know in the chat. Let me know using a thumbs up or anything. Okay, good. Yogesh, is there any doubt? Problem solved हो गया? Okay students, please take. Okay sweetie, very good, very nice. Now if that is the case, then here is another problem. Okay, here is another problem. Please solve it. I'll give you again exactly 3 minutes of time. Okay, just a second. Don't worry, we'll discuss the problem. Okay, what it is saying. Okay, just a second. It is 3 minutes, not 3 seconds. Yeah. So it is saying a wooden block is kept on a polished wooden plank whose inclination is increased gradually. Okay. Though they are telling कि एक वुडन प्लैंक था, ठीक है, पहले यहाँ था, फिर उन्होंने उसका जो इंक्लिनेशन है वो ग्रेजुअली इंक्रीज किया, ग्रेजुअली इंक्रीज करते गए, ठीक है. Now the block started slipping when the plank makes an angle 25 degree with the horizontal. So जो प्लैंक था इसके ऊपर पहले, मतलब ऐसा एक प्लैंक था, बॉडी था, वो स्लिप करने लगा जब ये वाला एंगल क्या बन गया 25 डिग्री, ठीक है. एंड however once started the block can continue with uniform speed. जब 25 डिग्री के लिए जब ये स्लिप होने लगा, it can continue with the what velocity, uniform velocity. Okay, if the inclination is reduced to 21 degree, इन्होंने क्या किया, फिर से उसका inclination reduce किया, फिर 21 डिग्री बनाया. So calculate the coefficient of static friction and what dynamic friction, that is kinetic friction. तो बताओ ये दोनों वैल्यू क्या होता है. Okay, let me know in the chat. Let me know students. You have exactly 3 minutes, 2 minutes and 59 seconds to solve this. अगर आप पूरा वैल्यू भी नहीं बता सकते ना, एटलीस्ट कहाँ तक आता है वो भी बताओ ना, तो भी चलेगा मुझे. Yes, very good, Tumkur students. Can I know the value of that? Is it possible to know the value of it somehow? Very good. Chitradurga students, very good. JNV Uttarakhand students, very good. Last 1 minute remaining, students. Please solve it. Please try to solve it. Others, let me know. What is the answer? Let me know both mu s and mu k. Okay, very good. I want both students. You are giving only one answer. What is this? Let me know. Let me know. Yaradra answer kodiyala. If you're giving only one answer, there's see over here you need to find both mu s and okay, just a second. Mu s and mu k. Sweetie, let me know. Krishna, let me know. Last 5 seconds. 4, 3, and 2, and 1. Okay, now over here. Observe this, okay? They said that the block starts slipping when the plank makes an angle 25 degree. So can I take this as alpha is equal to 25 degree? Yes or no? Because yesterday we saw what is happening? Angle of repose. Yes or no? Where the body just what starts to slide. So can I take angle of repose to be what? Let me know, students. What is it? Is it static friction? Yes. So can I take tan alpha? We know tan alpha is equal to mu s. And we know that tan 25 degree is equal to mu into s. And mu s is what tan 25 is. The value comes out to be 0.462. This is the value of what? Mu s. Now, over here, they said that if the inclination is reduced to 21 degree, so they are decreasing it such that the body will move with the uniform velocity. So can we know that in order to find the mu k, we have tan what? 21 degree. Yes or no? That is tan theta. That is tan theta. So can I take mu k to be tan 21 degree? Yes or no? Now the value of 21 degree is what? 0.383 students. Yes. So these are the two values. Did you get it now? Let me know. Let me know in students. Let me know in the chat. जल्दी बताओ students. Okay, good. Yes or no? Okay, good. Others तुमको उत्तर कन्नड़ा बागलकोट everyone let me know. Yes, very good. If that is the case, students, good. Then here is a homework question. Please take a screenshot of it such that you know that, okay, this is the homework question. Students, you need to solve this question when coming on Monday, okay? Try to solve this, okay? You need to find what is the tension. You need to find what is the tension in the string, basically. Okay? The tension direction is also given in this. You need to find it, students. Okay. Since we have only limited time, so I'm giving this as your homework question. Take a screenshot. Take a screenshot, everyone. Yes. And students, YouTube students, please take the screenshot also. Okay. Students, that's all for today. We'll be solving a lot of numericals in the last class. And if you have any doubts, let me know. I'm available here for what? 2 minutes. Okay. Let me know, students. Is there any doubts? And since the polls are not yet activated, there is no NPS. But yeah, if you want to give any feedback. Okay. Downgrade students, in the last class, we have talked about angle of repose and angle of what? Angle of friction. Angle of friction. So in that, wait just a second. Okay, here's a question. Okay, in that we know that mu s is equal to tan alpha and mu k is equal to what? Tan theta. Okay, see, Badari students, you can use logbook also to find it out, or you can use calculator since you are in the classrooms. Okay, if these type of questions comes in your let's say exams, they will provide you the logbook. Don't worry. Okay, to find the tan 25 degree. Okay, and if you have any doubt, you can be present in the class. I'll be here. Okay, and students from YouTube, thank you for coming and thank you for attending. If you have any doubt, let me know. You can get me through. I mean, you can reach me through Seed the group also. Okay, in Telegram. Okay, students, YouTube students, then take care. Bye bye. Okay. And yes, okay, sweetie, take care then. Bye bye, everyone. Take care. Have enjoy your weekend. Okay. Bye bye.